My dear students, good evening. In earlier videos, I discussed the t-test analysis. That is one sample t-test, and then I used the independent sample t-test, and in video number 572, I used a pair sample t-test. But t-test is used when we are comparing the means of two different groups or two pairs of the same variable. When we are comparing the means of more than two groups, then in that case we cannot use a t-test, or we can do that for various pairs of the two groups. But if you want to compare means of three or more different groups at the same time, then in that case we'll be using analysis of variance. So let me explain the analysis of variance. Analysis of variance, abbreviated as ANOVA, is used when we compare the mean scores of more than two groups. One-way analysis of variance involves one independent variable, which is referred to as a factor, and it has a number of categories like different levels. The dependent variable is a continuous variable or a quantitative variable. It compares the variability in scores between the different groups and the variability within each group. An F ratio is calculated. If F ratio is large, it indicates that there is more variability between the groups caused by the independent variable and then there is within each group. That is error term. A significant F test indicates that the groups different. However, it doesn't indicate which of the groups differ. For this, we will have to need to conduct a post hoc test. So in order to do that, let me go to my data file. My data file is here. This is my data file, and I'm using the same variable, that is marks in statistical analysis before training. There are 110 observations in this data set as well as in this variable, and I want to perform one-way ANOVA, that is one-way analysis of variance, and my independent variable is a program. It has three categories. One stands for general, two stands for academic, and three stands for vocational. So these are three different levels of categorical variables. Let me navigate to analyze and then compare means, and after that I'll go to one-way ANOVA, and after that I will have this window popped up. So I need to use this variable in the dependent list, that is marks in statistics, marks in statistical analysis and interpretation before training. And my factor variable is a categorical variable having three categories, 1, 2 and 3. So these are three different programs. One is general, 2 is academic, and 3 is vocational. After that I'll click on options, and within options I need to click on descriptives, and I also need to click on homogeneity of variances test, and then I'll click Brown, Forsyth and Welsh, and I need to click on this also, means plot. I'll continue, and I'll also do this post hoc, and in post hoc I should check Tucky's B test and also Games Howell, and after that I'll continue, and then I'll press OK. So I have this analysis of variance. This is one-way analysis of variance. So the very first table gives me descriptives. So there are three groups, as I mentioned earlier. The code 1 was for general, code 2 was for academic, and for the 3 was for vocational, and total number of observations are 110. 26 observations belong to vocational group, 59 to academic, and 25 to general. These are the mean scores of the three groups. So this means these are the average marks of students in statistical analysis and interpretation for those who studied in general group, This is the mean value of those students who are in academic group, and this is the mean score of students who belong to vocational, and this is their average score in statistical analysis and interpretation. This is the overall average. These are the standard deviations for the three different groups, and this is the overall standard deviation. These are the standard error of means, and these are the lower and upper bound of 95% confidence interval for mean. These are the minimum and maximum values. This table shows the test of homogeneity of variances, for which we use Levin's test, and the null hypothesis is that the variances of the three groups are homogeneous. That is, there is no difference between variances of the three groups, but the p-value of the Levin's test shows that this p-value is greater than 0.05. So we fail to reject the null hypothesis of homogeneous variances. So that is, the variances of the three groups are homogeneous. After that, I have this table for analysis of variance, and it has a between group sum of squares, within group sum of square, and total sum of squares, and there is the f stat, and the f stat value is 18.705, and the overall test significance value is 0.000. So it means that the difference between various groups mean is highly statistically significant. But in order to know which groups differ statistically differently, we will have to see the post hoc analysis. But before that, let me also share with you that we have conducted Welsh and Brown and Forsyth robust tests of equality of means, and both the statistics are significant. So it means that the means that the mean difference between various groups are significant. So now I'll interpret post hoc test, and post hoc test shows which groups mean are statistically significant. So here is this is the difference of means between program I and program J. So program I is general, and this is academic. So the difference between the mean difference between general and academic is minus 7.717, and here is asterisk. So it shows that this p value is less than 0.05. So the mean difference between general and academic, the absolute difference, is statistically significant. However, the mean difference between general and vocational is 3.90, and the p value is 0.207. So this mean difference is not statistically significant. The difference between academic and general, we have already discussed this, but the only difference is that here the sign is positive and here the sign is negative. So the absolute difference between the two is statistically significant. Similarly, the difference between academic and vocational is equal to the mean difference between academic and vocational group is 11.62, and that is statistically significant. However, the difference between vocational and general is not statistically significant, but the difference between vocational and academic, that is statistically significant. So it means that out of these various groups, the mean difference between academic and general and the mean difference between academic and vocational is statistically significant. However, the mean difference between vocational and general is not statistically significant. This is the homogeneous subsets. So this is a vocational program, this is a general, and this is a academic, and this is Stuckey-Bees test. And it says that the academic, the mean of the academic group is significantly different from the mean score of vocational and general group. Finally, to confirm this, we have plotted mean of the three groups, and if you look at this graph, it says that the mean score of academic group of students in statistical analysis and interpretation is much higher as compared to vocational and general. However, the difference between general and vocational is not statistically significant. Ladies and gentlemen, this is how we can use one-way analysis of variance for comparing the difference in means of more than two groups. This is very simple. If you have any question, you can ask me in the comments below this video. Kindly share this video with your students, with your colleagues, and with your friends, and share it in various WhatsApp groups so that it can reach to the maximum possible number of people. Thanks for watching.